Good evening, good morning, everyone. Yeah, let me just share my screen. Can everyone see my screen? Cool.
Yep.
Okay. This will be a, a short interaction of how exactly Flytectl is being used for interacting with Flyte. So just for all the newcomers, this is similar to like any other command line utility that we have. So currently we have different CLIs that we use with Flyte. We wanted to have another binary which can be pretty easily portable and distributable, that can be used by all the users to interact with Flyte. And I'll go over the use cases shortly, but this gives you like uh, all the interactions that you need to do with the Flyte environment. So just a overview of some of the use cases that are being covered in this. So basically, whenever you have to interact with Flyte, you create your projects, you create your workflows, launch plans, tasks. You create executions on those and run them on an environment where Flyte is deployed. Along with that, Flytectl also allows you to create like a mini Flyte environment directly using Flytectl. So you can just play around with that environment, which is basically whether it runs a Kubernetes cluster, KT cluster within a Docker container, and along with all the Flyte containers running within it. So that makes it very easy for folks to try the Flyte environment on their machine and not have to worry about setting up the entire thing uh, uh, either on a AWS or a GCP. This is on the machine. They can do this pretty easily. And yeah, so I'll just so the existing ways for people who have uh, using Flyte, there's already an existing Flyte console UI through which you can pretty much launch executions or launch a task or launch a workflow. You can provide inputs, visualize the graphs of how exactly your DAG is for your workflow. So and also we have a command line based Flytekit, which is Python based and which are also allows you to interact with Flyte in a similar manner, but through a command line interface. But the disadvantage with Flytekit is basically you have to install all the dependencies, which are pretty much part of the pip install. It takes, but builds everything and then brings you your Flytekit CLI for you. There are other alternatives where you have a Flytekit Java-based SDK, and which you can use for doing a similar interaction of creating, registering your Flyte entities or getting execution status through these SDKs. Or you can create your own client. That's another option you have. We already publish an SDK, and Flyte publishes it for multiple languages. I think Go, Java, and Python. So you can write your own client on top of it. Going to why Flytectl, but so one thing is it's pretty easy to install and set up. If you have a Mac OS, you can just do brew install it, and you have your Flytectl binary bundled with all its dependencies, and it's a cross-platform. So we have released it for Linux, Mac OS, and Windows, and these are continuously built through our pipelines. So any changes are being released for all these platforms. We'll be probably supporting more later on. These are the existing ones that we have. And also it's a very small footprint of this binary, and so which makes it very easy to install as well. And as I mentioned earlier, you can, if somebody wants to try Flyte, deploying a cluster or something, it's pretty easy to do it using this binary. So you just brew install Flytectl, and then you want to create a Flyte cluster, you can just do Flytectl sandbox create cluster, and there would be more demo at the end, which will tell you how exactly to create the sandbox environment and running those workflows. So it becomes very easy for you to interact with the Flyte environment and see the power of Flyte in general in a very easy steps. And along with that, like if you want to use it in your automation CI pipelines, there is also a GitHub action which allows you to install it as part of your CI. And if you want to have some creation of projects which are tracked through GitHub workflows or any other Flyte entities, those are pretty much possible now. And along with that, the main Flytectl has been written in a way that it properly mimics some of the kubectl style. So we have it's structured with nouns and verbs. So similar to how like Flytectl get a resource, or Flytectl get or update or create a workflow or a task or a launch plan or an execution. So we've structured our documents, all our commands in that way. So you have this the sub command, and within that you have the particular resource on which you want to act on. So you have Flytectl get workflow or Flytectl get execution. And I can just show you the main page where we have all this defined. So this is docs.flytes.org. So within the API reference, you should be able to see the docs for Flytectl. The install and configure is, as I mentioned, it's pretty simple to do it on OSX. We have to install Flytectl, and the upgrades are also similarly very easy. We're trying to make it much more simpler, providing it as part of Flytectl itself, like Flytectl upgrade or something that can self-upgrade it. And other operating systems also, right now we have just to install a script and that works on Linux. I think we have to, we'll probably see, like you think Windows is missing, we probably add an installation step for that. And the configuration is also pretty simple of how exactly you configure your local environment. So this is a sample configuration where you want, where your Flyte admin is running the local host and the port where it's running, some of the additional parameter, whether it's secure, and if auth is configured on the admin. And some of the other stuff is mostly for if you're using like faster iterations while registering, but basically won't be required if you're just using normal serialize. And so as I mentioned that, so this is how most of the commands are structured, like the command and the verb. And so create, update, delete, register, and the corresponding ones on how exactly, what are the kind of resources you will be interacting with are available in the nouns page. So I'll just go over one of those, like creating a project. So we have two ways you can create a project. You can specify it, all the important stuff that you need for creating a project on the command line, parameters like name, ID, description, or if there's another way, you can just have everything in a YAML file. and similar structure to what you have in the command line parameters, and it allows you to do the same thing. Now with the YAML, it gives you an additional benefit. You can actually do GitOps on all these files, and this is across all the other Flytectl commands. You can actually version some of these created files, and you can track them for any changes. And so creating an execution is also pretty similar. You can, any task that you want to execute it, you'll create an execution spec file. So this is like for a merge sort example, and it dumps you a YAML file, which is basically what are the inputs required for executing this particular task, and where you want to execute it, whether in a same project domain or you want a different domain and project for this particular task to be executed, and what version of the task it is. So whichever one you are fetching it. So if you're doing a get on the task and you have specified that you want to generate an execution spec for a particular version, week 2 version, so it will create a spec file with that information. The rest of the things like IAM role, kube service account, or anything related to permissions that are required for executing this this particular workflow will have to be specified. And yeah, I mean, so it becomes, and whenever you want to create an execution, you just pass in the spec file. So whatever modified file you have, you just pass in that file. And there are other things that we have part like relaunching and recover. Yeah, I mean, that is pretty much it. And I would like Yuvraj to go over a demo about this and show how to create a sandbox and create a sample execution on it. Yuvraj, I will hand over to you. Yeah.
Yes. Thank you, Prafulla, and good morning, everyone. So let me share my screen. Is it visible?
Yes, we see your screen.
Yeah. Okay. So for today's demo, we need an example. So we will take one example from Flyte snack, that is pima diabetes. So we can see in the case study, we have one example in ML training, pima diabetes. So what it is doing is, it is a pipeline for training and post model for a given data set. So we will just I will explain you quickly this workflow. So we are taking 3 inputs: data set, test split, seed, and then we have 4 tasks. So these tasks is basically taking the input and then producing an output and then passing it to the next task. So these are the 4 tasks we are talking about. First is the split. It will split the task. It will returns the model that fit task. And then we will pass the test data to predict the output. And then we have prediction. Now we will calculate the score from this prediction and the test data that we have. So this is the simple model we will use for today's demo. So first we will start the sandbox cluster. Okay. So first we need to move in a particularly directory, that is the ML training. In ML training, we have all the examples like house price prediction and pima diabetes. So here we will run the sandbox. We will start the sandbox cluster and we will pass the source directory to present working directory. And currently I have the sandbox cluster, so I'm not recreating it, but you can create it and you will get the output like this. So we have console available at 30081/console, and our Flytectl config is available at .flyte directory. So first, what we can do is let's start with the demo. So now we can see that our sandbox cluster is running. We can check that. Okay, so now, like if you want to create a config for this cluster, so we have a config command that I want to show you. So if you create that config file, it will automatically create a config for you in the home directory. And by default, Flyte automatically pick the config from the Flyte directory. So you can get the same Flyte config using the same command. And if you are doing it for a remote cluster, then you can use it like this, like by passing -- host. And now it will create the config for the remote cluster in the same way. Now, when you have config ready for the communication with the sandbox, yes, and now we will first serialize, we will build our Docker image. So for doing that, because we are running it in a sandbox mode, like a local mode. So what we will do is like, we will run the Docker build command inside the container, because we want the source code inside the container. That means we can run the Docker build command inside the container, and in our Kubernetes cluster, that image is accessible. So for doing that, we have a command in sandbox that will build the image inside the Docker container. I have the images, so it will from the cache, but if you don't have the cache, it will build one by one. And now your image is available. Now you want to serialize your workflow. Okay. So you need to pass the package name, like pima diabetes, and the image that we want, and the output file. And it will serialize the workflow. So now our serialized workflow is available in the directory that is flyte.tz. Now we can register. Okay, we can register this workflow. Workflow is registered. Now we can check it. Get workflow. Okay, so like we just registered our workflow, and then we get our workflow and we created a .url. So it created our .graph here. So we can see our graph. We have a split training dataset task that has fit, predict, and score. We have total 4 tasks that is available in graph.flyte.org here. So now our workflow is registered successfully. Now we want to execute that workflow. So for that, we will get the launch plan first. Like, what is the launch plan? So it will create a file, execute spec.yml. We can edit this file and we can change the input parameters. So for example, we make it 8. Okay, now we can basically create execution from this file. Okay, execution is created. Okay, well, so our execution is started running. So we can also check it in browser in the console that it is running or not. Okay, it is running. What is the input parameter? Seed is 8 and test speed is 0.37. And while it is running, we can like just make some changes in the Flyte code base. Okay, so this is the workflow. We can change anything for a demo purpose. Let's add one more input type, that is maximum depth type, and default is for needed in the fit. Okay. So we just made some changes in the workflow, and now we want to do fast serialize. So for that, we don't need to build the images because our dependency, we didn't make any change in the dependency. We just made a change in the code base. So we will just use py-flyte to create fast serialization. It is running. We can ready. We register the fast serialize proto. Now we can basically repeat the same step that we did it for the serialize package. Like first we want to get the launch plan. Now if you see the execution, basically launch plan, you get the new input type and default is 4. So we can change the value to 7 something. Now we can create an execution from the Flytectl. So we can check the console. So we just run this execution for the fast serialized input 8 and 37. We get the output, and this is the workflow that we run on the fast serialized output. So for this, we didn't build the image. We just did the fast serialize and then registered the workflow. It is running. So while it is running, anyone have any question?
Thank you for that demo, Yuvraj, and thank you, Prafulla, for introducing the Flytectl walkthrough. Questions, anybody?